In order to determine solubility, we're going to need to take a look at a solubility table. Here we have a solubility table that shows two different things. It shows ions that are usually soluble in compounds, and then it shows ions that are usually not soluble in compounds. Now, I said usually because there are some exceptions, and we'll do a few examples so you can see how we would use this table. Alright, let's start with a few compounds. So here we have silver nitrate, potassium iodide, nickel 2 chloride, sodium acetate, lithium hydroxide, and calcium sulfate. Let's take each one of these individually and examine them with our table of solubilities. Okay, we've got AgNO3, and what we're looking for is NO3 or Ag in our ions that are normally soluble or normally insoluble. And I find that NO3 is right there. And so what this means is that compounds that contain NO3 are usually soluble. That means this molecule will do this in solution. It will break apart into Ag plus and NO3 minus in water. And that's what soluble means. We're just talking about whether or not a compound is going to turn into its ions in water. So since we see that AgNO3 actually excuse me, is going to be soluble, then we'll put AQ there. Let's try potassium iodide. We're looking for potassium or iodine. And I actually see it twice on here. I see potassium right there. And it says that compounds that have potassium are mostly soluble. And there's no exceptions. I also see iodide on here. Iodide does have exceptions. I mean, in general, when iodine is found in a compound, that compound is soluble, with the exception of being paired with silver, mercury, or lead. So if this compound had been lead iodide, here we go, lead iodide, then this compound would have been insoluble. That means it would have been a solid. Even in water, it wouldn't have broken apart into ions. Alright, so potassium iodide is aqueous. Let's look at nickel 2 chloride. Now you might remember from last time that if it has chloride in it, it's normally soluble, and this has chloride in it. Is chlorine paired with one of the exceptions? The exceptions being silver, mercury, or lead? No, it's paired with nickel. So that's all the information we need. This is going to be aqueous. If even one of these is aqueous, then the whole thing is aqueous. Or, I'm sorry, if even one of these ions is soluble, then the whole thing will be soluble. Alright, what about calcium sulfate? Here I see sulfate. I don't see calcium, but let's see what the exceptions are. So normally sulfate found in a compound means that it's a soluble compound. Unless it's paired with, and again we're looking at the exceptions, calcium, strontium, barium, or lead. And this is calcium. So that means that this is going to be a solid. This will not break down into calcium 2+ and sulfate ion in water. What about lithium hydroxide? Alright, where do we see hydroxide? Now hydroxide is found here. On the normally ions are insoluble. So this is the opposite of what the top table is telling us. So normally we would assume then that lithium hydroxide is a solid. But it says that there's some exceptions. So let's see if there's an exception. It says unless it is paired with lithium, sodium, potassium, or ammonium. It goes further to say, though, that when OH pairs with calcium, strontium, or barium, that the solution is slightly soluble. So whether it is soluble or slightly soluble, we're going to take that to mean the same thing. So that means that this solution would dissolve into its ions. This would break down into lithium plus and OH minus. Alright, last one. Alright, sodium acetate. I see sodium and acetate both up here in the mostly soluble. So we can already assume it's going to be aqueous unless it's paired with something that's an exception. And as you can see in both cases here, for sodium and for acetate, there are no exceptions. Anytime you see sodium in a compound, that means it is soluble, and we would expect that it would break down into its ions. C2H3O2. So that's how you use the solubility rules to determine if something's going to stay a solid or break down into its ions.